So we have 5 examples, as I said, of doing an equation quadratic in form. They are basically all the same type as far as what you are looking for. What you are looking for is 2 things to tell you, hey, it's an equation that's quadratic in form. They are there's a typo in B, by the way, I just realized. They are the exponent on one is twice that of the other. Notice here we have an x to the 4th, and here we have x squared. So 4 is twice 2. Secondly, if it can be rewritten so that you see an expression or a term, if you will, that's being repeated, notice x to the 4th is x squared squared. So what's being repeated there is this x squared. Then you have an equation quadratic in form. So again, if one exponent is twice that of the other, and something is being repeated, you have an equation quadratic in form. It has to be both. It has to be both statements must be true. The process is to pick a letter, any letter, except for that letter that's given. So pick a letter that's different than x. A it is. Whatever is being repeated, call it that new letter. A is now going to be called x squared. Wherever you see an a in the original wherever you see an x squared in the original problem, right here and right here, we're now going to call a. So instead of x squared being squared, we can now write a squared. Instead of negative 5 times x squared, we can now say minus 5a. Plus 6 is still plus 6. So what we did was a substitution. The purpose of the substitution is to make the problem look easier. This guy is something that we're much more used to than the original problem. And now we solve under the guise of the substitution. How does a squared minus 5a plus 6 factor? A minus 2, a minus 3. If we set the first factor to 0, what do we get for a? And the second factor? The next step, as we just did, was to solve for under that new variable. We got a to be 2, a to be 3. But did we start with a? No, what did we start with? X squared. So now we back substitute. So x squared equals 2, x squared equals 3. Well, if x squared equals 2, what does x equal? Plus or minus the square root of 2. If x squared equals 3, what does x equal? I'm sorry? Plus or minus square root of 3. So that is the process. Rewrite it so it looks like a quadratic. That was this line here. Solve under that quadratic. Back substitute, solve for the replaced variable. this process will work despite what the equation looks like. You just might have to do some additional tricks at the very last stage there. So in part B, instead of 10x, please make that 10x squared. All right. So just like what we did in part A, instead of x to the fourth, I'm going to say x squared squared. And this satisfies my two properties. One, the exponent on one is twice the other. And two, I see something being repeated. The x squared. So whatever is being repeated, give it a new name. Z it is. So z is x squared. So wherever I see an x squared, I'm going to put a z. So how does that rewrite? Z 10 z. Good. How does z squared plus 10z plus 9 factor? All right. Setting each factor to 0, what do we get for z? And? Good. But did we start with z? No. We started with x squared. So if x squared equals negative 9, what does x equal? X equals plus or minus 3i. If x squared equals negative 1, what does x equal? Plus or minus I. Don't forget about a plus or minus. Remember, you include a plus or minus when you take a square root of an equation.